Good morning students. In today's class let us discuss about what is vector and scalar potentials. So here we have taken in the previous sections potential as a scalar function. Scalar potential we have taken which is represented by phi. Yeah? So like that, what is vector potential, how it is represented? That is the topic. Our topic is today about vector and scalar potentials. Okay. Here, the electric and magnetic fields are derived from. Thus, what we are finding out is electric and magnetic fields. This electric field and magnetic field, whatever we are considering, are derived from two potentials, that is first one phi and the second one is A. These two are here called as scalar and vector potentials. For deriving those, first we have considered some equations. What are those? Is Maxwell's equation. So now let us discuss about Maxwell's equation. So here what I have told you about, and knowing about vector and scalar potential, first we need to understand what are the potentials, those are how they are being represented. These are the vector, scalar and vector potentials. These are useful for deriving the electric and magnetic fields. In the next case, here we need to tell about Maxwell's equation. What are the Maxwell's microscopic form of Maxwell's equation? Okay. What are those? The first one is del cross A is equal to minus 1 by C dou B by dou T. This is one. The next. Del cross B is equal to 1 by 4 by Cj plus 1 by C dou E by dou T. Del dot B is equal to 0. Del dot E is equal to 4 pi. This is equation 3 and 4. So for deriving this vector and scalar potential, first we need microscopic Maxwell's equation. These are the four equations which are used for deriving this. So please write this. We already know these four equations. Here curl of electric field, curl of magnetic field, del dot B is divergence of magnetic and electric field equations. After writing these four equations, now what is our interest? To calculate electric and magnetic fields. For calculating electric and magnetic fields, we are utilizing Maxwell's equations. along that equation 3, that is magnetic induction. Magnetic induction is represented by what? By B, and is given by B is equal to del cross A. Thus I am writing it as equation 5. What I am taking? I am considering magnetic induction B is equal to del cross A, where A is representing x comma t, where x is the displacement, t is the time. This A is called as vector potential. Got it? What I am taking for calculating A and M fields, I am taking magnetic induction B, where B is equal to del cross A, and that A represents a function x comma t, where is x is the displacement made by the charges and the presence of electric and magnetic field. Okay, so here T is time. Please note this. For calculating electric and magnetic field, I am utilizing Maxwell's third equation, that is B and describing the vector potential. Now we got the value of B is equal to del cross A and A is equal to x comma t. I'm rubbing this. What is we have got? B is equal to del cross A, where A of is equal to x comma t. Right? Now what is our first equation, Maxwell's first equation? Del cross E is equal to minus 1 by C dou V by dou T. This is equation 5 and this is equation 1 as per previous. Right? Now substitute 5 in 1. What we get? Del cross E is equal to minus 1 by C dou by dou T. What is the value of B? B is equal to del cross A. Now from this both terms, the next equation is for del cross E is equal to minus 1 by C dou by dou T del into A. I am writing that this is equal to 0. If this term goes to that side, it becomes plus. I am simply writing this as 0. Now taking del common, what I get? Del common, del into P plus 1 by C dou A by dou T is equal to 0, and this becomes equation 6. What I have done, substituting the value of B in Maxwell's first equation. Maxwell's first equation Multiplying this here, taking common, del. I got equation 6. So please write this. 5, this is equation 1. Substituting 5 in 1. Then del cross E is equal to minus 1 by C 2 by 2t. Then del cross E is equal to this function we got. Is this clear? We got in equation 6. Now in this expression, what term we are having? E del into E plus 1 by C 2a by 2t is equal to 0. That means in equation 6, what is the last equation we got? Del cross E plus 1 by C dou A by dou T is equal to 0. This is equation 6. And next, what is the term we got? E plus 1 by C dou A by dou T is equal to that term here it is called as gradient of scalar potential, and this is given by phi of x comma t. Or simply it can be written as phi. This term is called as what? This term is called as gradient of scalar potential. So where phi of it is given by phi of x comma t. And also written as E is equal to minus del into phi. Here where this is called as electrostatic potential. This is called as electrostatic potential. So many new terms you are getting here. Electrostatic potential also you should remember, that is E is equal to minus del into phi. We know the value of A. Now taking equality for both the equations after completing this. What is scalar potential? It is phi, right? What is vector potential? It is A. Here both it represents x comma t and x comma t. But what is electrostatic potential? E is equal to minus del phi. Now I am taking E plus 1 by C dou A by dou T is equal to minus del phi. What I am doing? Equating this term to the gradient of vector. So now make this term to that side. A is equal to, if it goes to that side, minus del phi minus 1 by c dou A by dou t. You write this equation as, this is 7, this is 8. Now we got the equation 8. So please note this. Till equation 8, after writing that, when writing on the board, you also please note it. Now substituting 8 in 4. 8 in 4. What is equation 4? Del dot E is equal to 4 pi rho. We know the value of E now from 8, so substitute that. Del dot minus del phi minus 1 by c dou A by dou t is equal to 4 pi rho. Now multiply these two terms. Del into derivate minus del square phi, right? Then minus 1 by c into this term dou by dou t. Del dot A is equal to 4 pi rho. Directly I have written del into del dot A. Now you make all these terms plus and set minus to that side. Dou by dou t dou into A by this minus term to that side is equal to minus 4 pi rho. Right? Please write this. Then next we are taking one more term here by adding and subtracting to LHS. After this, let us move by adding and subtracting one term. What is that term? I am taking here 1 by c square rho square by 5 by dou t square to LHS. Only to the right hand side. For the previous, what is the previous equation? This is the previous equation. You can see in your notes. Del dot A is equal to minus 4 pi rho. This was the previous equation. Now for this LHS right hand side, I will add and subtract the term, this term. Okay, what is that equation using here? Del square phi minus 1 by c square dou square by 5 by dou t square plus 1 by c dou by dou t. This term I am writing del dot A. Here minus term now. Next here I will write plus term. Plus 1 by c square dou square 5 by dou t square is equal to what? 4 pi rho minus of 4 pi. What I have done? I have added and subtracted this term to the previous equation. This is plus minus term. This is minus term. Plus minus terms to the above equation. Now among these two terms, I am taking common. What term I can take common? Here you can see 1 by c dou by dou t, 1 by c dou by dou t I can take common, right? Taking common, you can write here taking 1 by c dou by dou t common. Only from these two terms I am taking. Okay? So what will be that equation? Del square phi minus 1 by c square d square phi by dou t square plus 1 by c dou by dou t common I have taken. You will get this term. Please say this. Del dot a plus 1 by c dou phi by dou t minus 4 pi rho. You will get this term. Now here I am assuming del square as 1 by dou square by dou x square plus dou square by dou y square plus dou square by dou z square. And from these two terms, this and this, what I can take common? I can take phi common. You see, please observe this. From these two terms, what can we take common now? Phi we can take common. Right? So now you take the term phi common here and take 1 by c square d square by dt square phi plus the same term I am writing 1 by c dou by dou t del dot a plus 1 by c dou phi by dou t is equal to minus 4 pi rho. Please write that. So in this, what we have specified, del square is equal to dou square by dou x square plus dou square by dou y square plus dou z square to dou square by dou z square. This term we can substitute here. And the next, substituting the value of del square in this equation. What the equation turns to. Let me write that equation. Del square value is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. This is the value of del square minus 1 by c dou square by dou t square. Here this term is regarded as square rectangle square. Got it? How you got this? Substituting del square value in previous equation. I am representing this term with square rectangle square and again modifying the equation, substituting these whole value in the previous, right? So what I get there? Rectangle square 5 plus 1 by c dou by dou t plus del dot a plus 1 by c dou phi by dou t is equal to minus 4 by rho. First assuming this as del square value, and this is the next term what we had already in the equation. We have reduced this equation to this form, where rectangle square is called as D'Alembert operator. Here this operator is consisting of what terms? It is consisting of all x, y, z flow of charge particles in the presence of electric and magnetic field with respect to the additional term what we have taken. Right? This operator is known as D'Alembertian operator. So please write this, D'Alembertian operator. This is done by taking Maxwell's first equation, right? Then the next term here is by taking equation 2. Let us see that equation 2. Considering Maxwell's second equation, that is del dot B is equal to 4 pi Cj plus 1 by C dou E by dou T. We get the same equation in the form of D'Alembertian operator into A minus del dot A plus 1 by C dou phi by dou T is equal to minus 4 pi by C into J, here where J is called as current density, phi as scalar potential and A as vector potential. Okay. So now there are two processes in this calculating of vector and scalar potentials. First, for that we have taken Maxwell's equation. Then assume the third equation, that is magnetic induction B where it is B is equal to 10 cross A, where A is regarded as vector potential, and substituting that value in equation 1, we got a scalar potential with E is equal to minus del phi electrostatic potential. And this is all the derivative part for calculating of vector and scalar potentials. Here we are representing these two terms phi. The two terms are phi and A. So with this topic is completed, that is vector and scalar potentials, which is important long answer question. In the next class, let us discuss what is about a gauge, what is Lorentz gauge, and what is Poynting